today. This should be the second video that you watch today after the unit circle and how it's formed. This video is going to continue our study into angles. More specifically, coterminal angles and what trig functions look like in the first quadrant. Now, if this video at any moment, if it feels too fast or you don't have a chance to write things down, remember that you can pause and rewind. So we're going to be talking a lot of vocabulary today. So we have this angle here. We're going to have an initial side, which is going to be the beginning position. It's going to move from this initial side. That movement is an angle measurement. We like to use theta in pre-cal to denote an angle measurement, So our angle measure, we're going to have two specific things to it. A number, which is going to tell us how far, and a positive or negative, which is going to tell us which direction. If it's positive, it's going counterclockwise. If it's negative, it's going clockwise. After we travel, it's going to have a final side. We call that a terminal side. In addition, we are going to have a vertex, and that's going to be exactly the same that you're used to with geometry. So we're taking this angle that you know from geometry, and we're expanding on it. So these four vocabulary terms, you're going to need to know. Now, we do have a very common place where our vertex is going to lie. This positioning is going to feel natural. It's going to feel comfortable. We call this position a standard position. It's standard because the vertex is going to be the origin of a Cartesian plane. Okay, now let's talk more specifics about a coterminal angle. Coterminal angles are two angles that have the same initial and terminal sides, but different measures. The reason why we have this is because of the different directionalities. And if I really wanted to get technical, it could be more than two angles because of the looping nature that these angles can have. So it can go a full 360 degrees all the way around the Cartesian plane and then a little bit more. But we're pretty much going to live with the idea that there are going to be two. So now let's take a look at a picture of what I mean. So in this picture, my red side is my initial side, and my blue is my terminal. The pink and the green are showing you different angle measurements of where I'm going clockwise versus counterclockwise, where I would have those coterminal angles. So now let's talk procedure. With our procedure, we're going to have two versions of these because we can either be in degrees or we can be in radians. So when you have degrees, you're going to add and subtract 360. Well, with radians, you're going to add and subtract 2 pi. Because remember, 360 degrees around a circle is 2 pi when we're talking about radians. This procedure is going to be very important. You've got to remember it. So our directions for a couple of examples that I would like to show you is we need to find a positive and negative angle that are coterminal with the given angle. So when you go to find these two angles, the first thing you have to ask yourself is, am I given a degree or a radian? And then add or subtract the appropriate measurement. So the first example that I would like to consider is 30 degrees. Take 30, add 360, as well as subtract 360. You should get 390 and negative 330. Answer is always going to be in red. Let's try that again. Example 2. Let's take a look at negative 150. So we're going to take negative 150, add 360, and subtract 360. So my two angles should be 210 and negative 870. Remember, Negatives in pre-cal with these just tell us a direction. Let's try one more. This time, let's take a look at 2 pi over 3. So I need to take 2 pi over 3 and add and subtract 2 pi. But notice that I'm not writing it as 2 pi. I'm writing it as 6 pi over 3. There is a very big reason for that. It's because 6 pi over 3 is the exact same thing as 2 pi. But in order for me to add and subtract fractions, I need a common denominator. So now when I go to simplify these, I'm going to have 8 pi over 3 and negative 4 pi over 3. Sorry, that had a plus there and it should have been a minus. So again, 4 pi over 3. So now we're going to take a look at trig functions in a Cartesian plane, more specifically in the first quadrant. In case you've forgotten what that means, here's our Cartesian plane, here's quadrants 1, 2, 3, and 4. We are going to live in quadrant 1 today. I'm just going to dive into an example. So if theta is an acute angle in standard position whose terminal side contains the point 5,3, I want you to find the 6 related trig functions. Okay, that's a lot. So let's unpack some steps here because I think that steps make things that seem very challenging a little bit more doable. So in this particular problem, your very first step is going to be to draw the triangle. So I'm going to have my Cartesian plane here in a second, and I'm going to put the point 5,3 in my Cartesian plane. So here's my x and y coordinate, here's 5,3. So from here, I'm going to need to draw my triangle. Theta is going to belong right there. From here, we need to determine all of the side lengths. So 5 is going to be my horizontal distance, 3 is going to be my vertical distance. Now we have to figure out how we're going to do that hypotenuse. You can either use 45, 45, 90, 30, 60, 90, Pythagorean triples, or our good friend, the Pythagorean theorem. So for this particular problem, I have to work out the Pythagorean theorem, and I find that the missing side is 34. Now, we just need to find the related ratio, or in this case, ratios. So from this theta, you're going to see I'm going to label my triangle opposite, adjacent, and hypotenuse. So I can find sine, cosine, tangent, cosecant, secant, and tangent. So when I go to find sine, I'm going to have 3 over 34, but I cannot have the square root on the bottom, so I rationalize it. Same thing for cosine. I'm going to have 5 over root 34, but you're not allowed to have that, so you have to rationalize the denominator. Tangent is 3 over 5. Now what's nice is if you set it up this way and you have the related sine, cosecant, cosine, secant, and tangent, cotangent, all you have to do is reciprocate those fractions. Let's try it again, and I'm going to kind of change the problem a little bit, but fundamentally you're going to be doing the same thing. So what I want you to do is use a given point on the terminal side of an angle to find the value of the trig function indicated. So instead of finding all 6, this time I only want you to find 1. Always start off with drawing a picture. Secant is hypotenuse over adjacent. So when I fill in the information we know, my horizontal distance is 11, my vertical distance is 8. That's not a special right triangle, so I'm going to have to do Pythagorean theorem. When I do that, I find that c squared is 185, so my hypotenuse is the square root of 185. Let's go ahead and label my triangle. And now I can find the related ratio, which is the square root of 185 over 11.